So section 12.3 is the law of sines. And as you're going to see, the law of sines is completely different than sine. This is the law of sines. It's made up of three ratios that equal each other. And as you know, capital letters are angles and lowercase letters are sides. So we read the law of sines like this. The sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. Now when we will apply the law of sines to a triangle, we will only use 2 out of 3 of these ratios to write a proportion. So it may very well be that we use those 2 ratios to make a proportion. Or maybe we use those 2. Or of course, maybe we use these 2. It will all depend on what the triangle is giving us and what we're being asked to find. And of course, when we set up any equation, including this proportion, you can only have one unknown. Now, one major distinction between the law of sines and regular sine is that regular sine can only be used for right triangles, but the law of sines can be used for any triangle, including right triangles. In fact, if you apply the law of sines to a right triangle, setting up your proportion and solving it will simplify to regular sine along the way. Okay? So let's take a look at an example. Find the missing side or angle. Round all answers to the nearest centimeter or degree. All right, so in the triangle ABC, which we have, there's our missing side length, W. Now we must notice that this is actually side A because it's across the triangle from angle A. Remember that sides correspond to the angle that they are opposite of. So in setting up the law of sines, it's important to note that that W is actually side A. Now, we also know angle A's measure, we know angle B's measure, and we know side B's measure. So if we write out our law of sines, which you don't really have to write it out to solve a problem, but so that we see how it's plugged in here, sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. Well, we know angle A is 79 degrees. We know side A is what we're trying to find, W. We know angle B is 52 degrees. And we know side B is 28. So this is the ratio that we left out for this problem. We have our proportion now, and it has just one unknown, so we can solve it. And we know that you solve a proportion by cross-multiplying. So W times the sine of 52 degrees will equal 28 times the sine of 79 degrees. We're solving for W. Right now it's being multiplied by the sine of 52 degrees, so we need to undo that multiplication by dividing both sides of the equation by the sine of 52 degrees. Of course, those will cancel out, and we can plug all of this into our calculator to get our answer. So I plug in 28 sine 79 divided by sine of 52. Enter. Since they asked me to round to the nearest centimeter, I'm going to round that to 35 centimeters. Second example. Same thing, we're solving for the missing side or angle. In this case, it's angle A that we're looking for. So, let's see what else we have. We know side A, so that means that sine of angle A over side A will be a ratio that we'll use in our proportion. Then we know angle C and we know side C. So that's the other ratio that we'll set up in our proportion. So this time I'm not going to write out the law of sines to start. I'm just going to write out my proportion. Sine of angle A over side A equals sine of angle C, which is 42 degrees, over side C, which is 29. Now we know that we're solving for an angle, which means we will have to use the inverse sign to get that angle by itself. All right? We solve a proportion by cross multiplying, but I'm not going to do both parts of the cross multiplication here. I'm going to multiply that together, but once I do that, 36 times the sine of 42 degrees divided by 29, I'm going to not do the other part of the cross multiplication because just doing that part got me my sine of angle A by itself. So it would be totally unnecessary to multiply 29 times the sine of A, because then you're just going to have to go and divide by 29 on both sides and put that 29 right back where it came from. So save yourself 2 steps and just do half of the cross multiplication. Now this is the point where we need to get the angle A by itself. And we talked last week that to undo the sign, we take the inverse sign. But whatever we do to one side, we have to do it to the other side, right? So the inverse sign undoes sign, getting us angle A by itself. And now I can plug everything else right into my calculator to get my angle. So second sine 36 sine 42, close my parentheses, divided by 29, close my parentheses, enter. They wanted me to round to the nearest degree, so that's going to be 56 degrees.